Hi, welcome back, or welcome for the first time. I'm Andy. If it is your first time, this is a great video to start with, because last time we did the really boring, annoying stuff of getting a game framework ready. This time we're going to just write a game. It's going to be fun. We're going to just plow on. Okay, so nice short video. It's going to be a short video. All right, so we've got this game struct, which is where like all the game logic's going to go. We've got like a direction that the player is facing, and we've got a canvas that we can draw on. And this is just some, stuff to make the frame rate. So what we're going to do is we're going to make ourselves a thing which is for like the specific game that we're writing, and the direction's going to go inside that thing. So the game we're going to be writing is a snake game. So let's just have a property called snake. And we're going to put the direction in there, like I said. Oh, goodness me, typing is challenging. Direction is going to go in there in a second. So when we create one of these game things, it's going to have a snake in it, which we're going to have to make. So let's make ourselves snake.rs, and inside there we're going to make ourselves a struct called snake, and we're going to make ourselves that new method that we just said existed. It's going to return a snake. Snake's got nothing in it so far, so it should be straightforward. And now if we bring that in here, come on. This needs to be like a module. Now we can bring it in. There we go. Right. So, all right. So snake's not used for anything. Let's put the direction in it for a start. So like so, and then when we create one, we've got to set its direction to up. So we'll steal that code from the game thing and put it in next. So now we've got a snake. It knows which direction it's facing. Doesn't know anything else yet. And the game has got a snake inside it, and when something happens, the key is pressed, we need to set the direction. So what should we do? Should we move this code into snake as well? No, let's just have a... Let's not have anything that's to do with like keyboard events or anything like that in our... Oh, but now the game implementation... Yeah, we'll have to call set... Let's call setdir or something, right? So that then this snake code knows that something happened. I think this is right, yeah. Otherwise it's going to be really weird that we'll have a snake game where... like we're handling a time step happening, but we're not handling the keyboard being pressed, which would be very odd. So this way we have like visibility inside our snake game code of the fact that direction is getting set. So it needs to take a mutable reference to self for that to work. All right, it's looking good so far. So when a key gets pressed, we set the direction. We might also want later some other key presses might cause things to happen. And then when a time step happens, we want to do two things. We want to tell the snake like a time step happened. So let's call that method step as well. And then we also want to render, so let's have a step method, doesn't return anything, and doesn't do anything yet. That's where we're going to like update the snake, like move it or something like that. And then we also want to do some kind of rendering. So why don't we just have another thing called snake render, which I don't think is even going to be a struct. It's just going to be a thing that renders a snake onto the screen, onto a canvas like this. It's going to take in I guess it could take in a context. No, let's pass in a canvas. We'll pass in a canvas and a snake. And so we're going to need a thing called snake render, which we'll put in a separate module. Well, everything, like maybe there should be a subdirectory called snake or something, but anyway, this will do. All right, save it, should turn up on the left, and then make it be a module. And then it's going to have just a public function render, which takes in a canvas. And that means, the reason why I'm doing it, part of the reason why I'm doing it like this is that this is going to take in a snake. I want the rendering code to be like totally separate from the snake code, so that we can't accidentally modify the snake when we're rendering the snake. That's my plan. All right, so now we can do this, and the rendering code that we've got so far, which is obviously going to change, is going to go in that render function like this. We're almost ready to start. I know I said we were ready to start already, but we're almost ready to start. So this is not okay code. Why are you not troubled by this? There is no self, so this is definitely not okay. Gonna give me an error? Maybe soon. Alright, so meanwhile, I really would like you to give me some errors to tell me that things are not right. Oh, I think maybe I haven't saved. Yeah, okay. Yeah, right. So I hadn't saved the changes to lib.rs. I told it to update lib.rs to make this mod snake render thing appear, but then I hadn't done a save that saved that file, so I'd modified it without saving it. So everything was very confused. All right. So what are you worried about? I need to bring the trait in like so. Yeah. Not using snake yet. Well, that's okay. We'll use it in a minute. What other errors are there? Don't need that import here anymore. Or that one. That's nice, isn't it? So the rendering code knows about canvases. Like so. Knows about HTML canvas element and canvas rendering context 2D. And snake knows nothing about anything except the direction the snake is facing, and soon some more stuff. All right. So how do you implement a snake game? Well, you need a snake body and a snake and an apple, right? So the body is going to be, I think it's going to be a vec_dec of point. We'll make a point struct, why not? And there's going to be an apple, which is going to be the current location of the apple. It's going to be a point as well. And there is such a thing as a vec_dec, so that was a good guess. And we're going to let's make a new file. I like my structs to live in their own files. That's why dir is in its own file. So we're going to have a thing called point, which is going to be a module, and it's going to include a struct called point, which is going to be, well, it's going to be a position. So I think it's just going to be, like U8s will do us, because the way we've designed this so far, and we maybe want to change this at some point, but the way we've designed this so far, we've got this HTML page, and our canvas is 22 by 22. So the coordinates of positions are never going to be bigger than 22. So that should be okay to fit in a U8, I mean. So now we've got a point. So a snake's body is a list of points. The apple is a single point, and a snake can be looking in a direction. I guess the apple should be after the body and direction are properties of the snake, and the apple is separate. We could have, there might be more here, like, I don't know, if there'll be a high score or something. So a vec_dec is like a vec, except it's really good at allowing you to add things on the end or remove things off the end, and add things at the beginning and remove things from the beginning. Because the way it's structured in memory, it it's not just always starting at 0 and going to the end, but it's like a ring buffer. So it could be, half of it could be at the end, half of it could be at the beginning, and it just abstracts that from you so that you don't have to know that that's what's happening. Or another way of saying that is it's a double-ended queue implemented with a growable ring buffer. It means that you can push back and pop front, which is what we're going to be doing to a snake body. And when I used to write snake on the ZX Spectrum, I used to have to implement something that looked a bit like this manually. Otherwise, it was too slow for the Spectrum to handle. And then in the interim, I've written a whole load of snake games where I didn't bother doing this because having just an array and shuffling all the items in it was just easily fast enough. And now I'm back to a double-ended queue implemented with a growable ring buffer, but I didn't have to implement it. It's all done for me. So beautiful. All right, so the body is going to start out looking like something. So let's have a function that does that. And the direction is going to be, I think it's going to be, no, it'll be up. Yeah, that's fine. And the apple is going to be at a random point, I guess. So we'll have a function for that too. So what does a new body look like? Well, it's a vecdec of point. So how do you make a vecdec? Are there any examples here? Push back, push front. I guess, you can vecdec from an array. That's what I want. Yeah, okay. So I just want an array.into where the values inside there are points. Let's just do X and Y explicitly like this. So basically when you start off, we're going to hard code for now. No, shall we? Yeah, we're going to hard code for now that the size of this is 22 by 22. So we'll say that all the X coordinates are 11 and the Y coordinates are going to start at 11 and then go down from there. So the front of the snake is, let's make these public. Let's go and look at that. So this should be public properties of the point. So we're just going to have a bunch of points that are going to start at, come on, what am I doing wrong? They're going to start at 11, 11 and then go 11, 12 and so on. And the length of the snake is going to be knowable from the length of this vecdec. It'll start off as 5. So I think that'll just be your score. So in a minute, hopefully, we're going to be able to render something on the screen. So now we've got a snake body, and we need a random point as well. So please create that function for me. I wanted it after the new body, really. So, okay, what are we going to do? Well, we're going to need rand. We're going to need the rand crate, I guess. Yeah, I think so. Seems happy. And then to get a random point, I think we need it's like something called like a thread rand or something. That doesn't exist. Something to do with threads. Why am I not getting auto-completion from this? Come on, this is supposed to be a quick video. Well, we'll return a point for a second while it's building that index. So it doesn't moan about that at least. All right. Okay, now we've got something. So I think there's a thing called... we can just ask for a random number. We can make a random number generator. I guess we should make a random number generator somewhere and hold on to it in our or just call RNG. Yeah, I think we should call RNG. Shall we hold it in our state? I hate global variables. So let's stick with that. Let's be true to our principles. Hold on to a random number generator, which we're going to get by calling rand RNG, I think it was. Yeah. Or maybe we should, if we're not using the thread local one, let's call make RNG. Is that going to give us construct and seed a random number generator? Perfect. All right. So now we're not using the one that everyone else is using. We're just using our own little one. Now, what's the problem here? Oh, okay. This needs to be, we need to know a specific type. So we could, I think, is that the specific type? No, that's another trait. That's another trait. Okay. So make RNG returns a din seedable rung. So we could just, I'm wondering about the types of this. Like, it would be nice to just make a specific one and then not have to use generic types on our thing. Let's just say it's a thread RNG. Is that a specific type? Like so. And then I think here we could just call thread RNG new or something like that, right? How do we make one? Thread RNG default. Looks right. Does that make one with random numbers in it? What does it say? Telling us about security. Default doesn't say. All right, well, we're just going to have to check whether that gives us different numbers every time. Hopefully it will. All right, so now we've got a random number generator. So now we can generate random numbers with self dot. No, hold on. This is not a method on self. Let's make it a method on self. That'll be useful. Have I already overcomplicated this massively? I could have just used the thread local random number generator, but I hate global variables. And that is one of my values, and I'm sticking to my values. All right, so we don't want the next U32. We want the next U8. So I guess we can do next U32 and then just sample, or next byte. Is there a next byte? Fill byte. There's a fill bytes. Oh, I tell you what. Let's get the next U32 and then percent it to the size of the arena, which is 20. Like so, because, and then should we just cast that to U8 because we know that it's smaller than 21, smaller than or equal to 21. Let's make this into a function for a start. Let's call it random with a random dimension, I guess. So, and then I guess we could give the, no, that's fine. Right. So that now needs to be a mutable thing because it's going to modify our random number generator. And this should be self.random point. Oh, there isn't a self yet. Aye. Okay, so we need to make the random. Oh my goodness, I'm sorry. This is fine. We need to do it differently. So we need to make ourselves a random number generator first, which we're going to pass into here. But before we pass it in, we're going to use it once by calling random point. Random point. I can do this by passing in a mutable reference to RNG into random point. Random point is no longer going to be a method. It's going to be a function that takes in a mutable reference to a random number generator, because then I can use it before I've got a self. So RNG, which is a mutable reference to a thread RNG. I think that's what it's called. And that's going to call random dim twice. Now, I could make this more flexible, but right now the X and the Y dimensions are both exactly 22 in size, so you ain't going to need it, so let's not do it. So, I mean, arguably we ain't going to need random number generator that's independent from the rest of the world, but so lovely. All right, so yeah, so this should be returning a U8, and we should as U8 it. We could into, but then, or try into or something and panic, but we know for sure this is going to be less than 21. I mean, it should be between 1 and 21 inclusive, I think. So I think maybe I want that. We'll see. If Apple starts appearing outside the, like on the edges of our map, then we've got a problem. So the reason why I'm adding 1 and stuff is because I'm going to have a 1 pixel border around the edge. So I don't want the apple to appear on that. Now, RNG needs to be mutable. And some stuff's unused. That's fine. Let's make these things public because we're going to use them in a second. Tell you what, direction maybe doesn't need to be public. Maybe RNG as well. So maybe just the apple and the body are the things we're going to draw on the screen for now. And RNG is not used, but it will be. Fine. All right. So we've got ourselves a snake with a body. When we call new, we have a snake with a body and a randomly positioned apple. I probably should have not done the randomness yet, but because we haven't rendered anything yet. So rendering takes in a canvas and a snake, and then it draws the snake on the screen. So what I want to do is I want to draw a black rectangle. So I'm going to set the color to black, and then I'm going to fill a rectangle from, I don't know why these are F32s, yeah, no, F64s here. But they are. And now it's going to be canvas.width. And then I need to turn it into an F64. Maybe that into will work, we'll see. Canvas.height. Maybe? Does that work? Seems happy. Okay, so we're going to draw black. Then in kind of a grey colour, I think, we're going to draw a border around the edge. So let's do 777. So that's going to go from 0, 0, 0 to the width again. Oh, let's get hold of the width and like this, because this is going to get annoying. Width and height of the canvas. So yeah, having fiddled with the canvas a bit before, I know that. Is that going to work? I know that in order to get the width of a canvas, you can't get it from the context very easily, but you can get it from the canvas, which is one reason why passing the canvas into this render function was good. I also think it's just nice to have that context be live only for the life of this render function, because that's the way these contexts work. When you call get context on a canvas, it only should live very temporarily. All right, so we've drawn a thing across the top. So now we're going to go from W0 to WH, and then we're going to go from WH to 0H, and then we're going to go from 0 to H, like this. I think that's right. And that should draw as a grey rectangle. So I guess we better test that out, hadn't we? Still haven't used the snake yet. All right, so build our code the same as we did in the last video. What is wrong? What is wrong? Oh, the rand crate doesn't work without the WASM JS crate feature. So when we did cargo add rand, we should have added WASM JS as a feature. I thought that's what it said. Maybe it wasn't rand. What is complaining about this? Oh, get random. So let's try explicitly depending on get random. What features are there in rand? Nothing that looks like the thing we want. So I think we have to explicitly add get random with that feature turned on. Except it says that's the wrong name. Oh, it's get random without an underscore. Maybe we should read the documentation it told us to read. Let me do this on another tab so you don't get the flash of my history. Okay. So what does it say? Oh, well, this is the get random documentation. So maybe we just, I wanted the rand documentation to tell me how to turn this on in rand. I think we're fine. Does it build? Oh, I've done that. Okay, that built. Fine. So let's refresh. Now, what's happening? We have not got what we expected. Why not? Yeah, I know that body and apple are not red. X and Y are not red. Yeah, because we're only rendering hard-coded stuff. But I still think render should be drawing stuff. And well, hang on, I've done this wrong anyway, haven't I? Somehow I got really confused there. All right. So what I wanted was to draw a black rectangle across the full screen, and then a grey border around the edge. But it's not working. Something's up. Okay, so it's drawing a black rectangle, which is good. I think that is covering the entire canvas. Yeah, it looks like it. So, all right, so that's better. At least we're not totally lost. So what are we doing wrong here? Oh, is it maybe that it needs to be one wide? I think it needs to be one wide. Yeah, that'll be it. So this should be width -1, I guess. width minus 1 to width, and then height minus 1 to height, and then this should have a width of 1, and these are just wrong. We'll just get rid of them. So yeah, I think on my lines that I was drawing on the canvas had a width of 0. All right, so we're nearly there. We just did this bottom one wrong. So let's have a look at what we did there. So this one is the one that is at height. This one, right? It should be going from zero to width. That's its problem. You can't go backwards. I think it's not allowed. There you go. All right, so now we've got a border around the screen. All I was trying to do was draw a border around the screen. Okay, so we have done that. So let's draw the snake. And the way we're going to do that is we're going to loop through the snake's body. So snake.body. And I guess before that, we're going to set the color to be, the snake should be green. Don't let anyone tell you otherwise. Should be about 0D0, I reckon. And we're going to fill a rectangle from the X coordinate and the Y coordinate to them plus 1. P dot Y, that should be. P dot X dot into plus 1, P dot Y dot into plus 1, right? No, it doesn't know what to into it, but if we could, one trick that I thought was maybe a nicer way to express this anyway, was to do that. Add 1 to P dot Y before intoing it. Is that going to work? Okay, it's reasonably happy, but we should be taking a reference to snake.body and looping through that. Because, yeah, snake is a reference already. Okay, so now we should be drawing the snake's body. We should be a line. Oh, that's big. That's not what I was expecting. What have I done? What have I done? Hang on. What are the coordinates of fill rect? X, Y, width, and height. Ah, okay. Okay, we've done it all wrong. We've done it all wrong. Okay, so these should just be, the width and the height of this should be 1.0. But that, surely I just got lucky with these ones then. So 0, 0, width of width, height of 1, fine. This should be a width of 1 and a height of height. And this should be a height of 1. And is that one okay already? Yeah, I think so. Is that going to work? There we go. Look, so we've got a snake looking upwards, ready to run off. Let's draw the apple. Apples are red, like so. We're going to just draw it like this. Snake.apple.x, snake.apple.y. Simple. We're drawing a snake. No, an apple, I mean. That didn't work. Why not? Yeah, it did work. And look, it goes to a random place each time. Oh, look, it's sometimes off the edge. So I've done that wrong. It's never off the top or the left, but sometimes it's off the bottom. Sorry for the flashing. Sometimes it's off the bottom or the right. Okay, so I was right first time, wasn't I? That's a nice way of putting it. Should be percented by 20 like this. I don't think this is a very good way of getting a random number, by the way, but it's like random enough for a silly game. Okay, so the snake's facing upwards. It's ready to move. Every time step it should move. Let's implement that. So every time step. Currently we do nothing, but based on the direction, we should add a new point at the front and remove a point from the end unless something we haven't done yet. So we won't do that yet. Okay, so we're going to say, based on the direction, the amount we're going to move our point by is going to be self.dir, that should be. If we're facing left, we're going to move our point by -1, 0, right? That's kind of how I'm thinking we're going to do it. I think that's okay. Let's try that. And then if we're moving up, that's 0, -1. If we're moving right, it's 1, 0. If we're moving down, it's 0, 1. So this is going to be like this, and then self.body I guess it's, can we use square brackets? We could do something like this, couldn't we? This should be renamed. This should be named move, not move, because move is a keyword. So we're going to say move by this move, and our point doesn't know how to do that, but that's okay. We can tell point how to do that. If we go look at point, we can say impl add brackets. Now this is going to be a pair of U8, U8, I think, although we might have to change that in a minute. 4 points. So basically this is how do I add a 2-tuple to a point. The output is going to be a point, and it's going to be a new point. Hang on, we want plus equals, don't we? We want add a sign. Oh, okay. Did I use plus equals? Yes, I did. So we don't want add, we want add a sign of this thing. Then we don't have to say the output type because we're not that. This is the add is for implementing plus, and add a sign is for implementing plus equals, essentially. Oh no, I just missed a diagonal bracket. It was giving me a very confusing error message. All right, so self.x plus equals RHS dot. Can we just match? This would be easier, wouldn't it? X, Y. Self.x plus equals X, self.y plus equals Y, right? Hold on. This can't be a U8, U8. It needs to be signed. And I think it's going to cause us pain anyway. So let's see what we were doing. Yeah, these -1s don't work anymore, which does imply it is going to work. All right, so that means we can use an I8, and that will be okay for us, at least for now. So we'll make these I8s because that's like between -128 and 127, and that's fine. But now how do you add an I8 to a U8? This is so annoying. I guess we're going to need to do self.x equals self.x dot into plus x. Will it let us into it? What has that done? Has that converted self.x into an I8 and then turned it back into a U8 implicitly? Because that seems a bit dangerous. No, it doesn't know what to do. It was just waiting to tell me. So what we want is to convert this x into a... See, like whenever you start mixing up numeric types, it gets really awkward. And it's making me think that we should make a point be an I8 all along. And then this will just be fine. I mean, at some point, I8s might not be big enough to handle what we want to do, in which case we'll use a different type. But for now, that's fine. This should take a mutable if it's going to modify body. We've got a problem because this should be returning an I8, which still works because that still fits inside an I8. All right, where were we? We were saying every time step you move, the front of you moves in the direction you're facing. So let's test that out. And if I press a key, I can actually steer myself, which is nice, isn't it? Now, if we were writing a real Snake game, we'd probably want to queue up your key presses as well. That makes it feel a lot nicer, but we won't do that, I don't think. Okay, so we can move that front dot around, but the rest of our body's not moving. And the reason for that is we actually don't want to change. That was wrong. We want to push. We want to push at the front. The current front, which I think should be just front. Well, no, we need to copy it. So we're going to do let front equal self dot body dot front, and we know that it's never an empty thing, so we can just unwrap that, and then we'll add move, and then we'll push. That's what we'll push, like so. Oh, we want a clone of that. Oh, point can't be cloned. We better clone it. We better make it clonable. I mean, I think we should make a copy, don't you? Let's make it copy, and then we don't have to do that dot clone there. Like, this is such a simple little bit of data, it seems fine to be able to copy it. So now we don't need clone. We can just dereference it. There we go. So now front is a point. Now we can add move to it using that code we just added, push that onto the front. Now the snake will grow. So now we could be writing like a Tron game. Now the weirdness that you're seeing there is just to do with scaling. There's a bug in Firefox where sometimes the rendering looks a bit wrong. It's not our fault, I promise. Here comes our snake back again because I turned it around. Right, so growing. Well, that's not what we want, is it? So we also want self.body.pop back. And this is where I'm saying that a vec just does these very efficiently. You could do this with a vec, push something on the front and it would shift everything along one, and then pop back would just remove the last one. But this is just, it does that, but it's more efficient. Okay, so look, it looks like a snake. It moves when we tell it to, and so on. So now there is something. When we eat an apple, we need to get longer. So we need to deal with eating an apple. And and then we need to deal with getting longer. So let's do that first. So once we've moved, we know where front is. So I guess just before we push front on, let's handle the eating an apple. So this is like, figure out where our head is going to be. Figure out where head will be. Check for eating apple. Move snake forward. So if self.apple equals front, then self.eat apple. How about that? And we better make an eat apple method. And you can't compare points yet, so let's have point implement partial eq. Now, eat apple is going to move the apple. That's the first thing to say. So it's going to take a mutable reference to self, and it's going to say self.apple equals random point self.rng reference to. They're going to let me do that? Seems like it. Okay, so when you eat an apple, the apple moves. Let's try it. Hey, it works, it works. Now, without that queue of user input, it's really no fun. So I think I'm going to have to implement that before I can call this game done. All right, so we also need to grow. So I think the way we're going to grow is we're going to have a length, which is not just the length of the body. It's going to be, it might be longer than that, and it's going to gradually extend the body. You'll see. All right, so let's say len. Let's make this a U size, because we're going to compare it with the body length in a minute, I think. So we'll have len be 5. Let's have len be 5. What we could do is make it be whatever the length of body. So if we change new body, this would mess up, but it's okay. All right. Now, what's it complaining about? It's not used. Okay, so when we eat an apple, we're going to increase the length by, well, should we increase it by a random amount or by 5? Let's increase it by 5. There's nothing wrong with that. Now, how this is going to work is, instead of it just always removing our tail, we're going to say something like if self.len is what is it? If the length of the body is, yeah, so if self.len is less than or equal to self.body.len, then we pop back. Is that right? This is just this is the wrong way round in my head. What in my head, what I want to say is something about the length of the body. So if the length of the body is at least the length it should be, then we pop back. If not, allow our body to grow until it is the same length as len. That's what we're going for there. So we don't need technically we don't need the greater than part of that, greater than or equal, but you know, defensively that feels sensible to do. Okay, look, we're growing. Did you see that? So it's working. So we've got this length that we should be, and it now just expands to be that length when you do that. Now, when I used to implement my own ring buffer, or something a bit like a ring buffer, sometimes you wouldn't grow immediately. You would only grow a bit later on when the kind of ring got round. But the way this is implemented, it's fine. Anyway, a few other things we should do. We could decide whether or not we're going to make if the apple is on your body, you don't die be a rule. That's a rule I used to like, but I used to accidentally implement that because I used to implement my snakes with just color recognition to decide whether you'd collided or not. But anyway, okay, so stop playing. All right, so what we're going to do first, you've got to be able to die. And when you die, what happens? I guess when you die, then we just stop. Maybe show a score or something, but for now at least we'll just stop. So let's just have alive as a thing. We start off alive. And then if you die, then you're not alive anymore. So check for collision. Let's just say self.check for collision. Let's just call it that, shall we? Like so. It's going to take a mutable reference to self again. Everything taking mutable reference to self, which doesn't feel nice. Right, so what is it? If we hit an edge, so if self dot. Oh, hang on, we should pass in front, shouldn't we? Yeah. All right. So pass in front. Pass in a copy of front. Why not? Front. So if front.x is less than or equal to 0, or front.x is greater than or equal to 21, I'm going to say, or front.y is less than or equal to 0, or front.y is greater than or equal to 21, then self.dead equals true. Oh no, self.alive equals false, isn't it? So this is just hitting the edges of the screen, and we need to do something. If you're dead, let's just say you don't move. So this time step you will move. If not, self.alive, alive, just return, do nothing. Well, in a minute we'll need to check something, but for now we'll do that. All right, let's see if that works. When we hit the edge, do we now stop? So the way I did that was I let it step forward that one more step, and then so yeah, within this function, within the step function, we only stop when we're dead at the very beginning. In here, we check for a collision, but then we continue to move the snake forward and also eat an apple, which is probably not relevant. So collisions with the side are now dealt with, but what about collisions with your body? So we want to say if self.body.any point equals front, then self.alive equals false. We could do this all in one big if. What have we got here? I guess it should be star. Yeah. So if any point on the body hits front, then we die. You might want to say, like, if you actually hit the last point, which is about to move, you don't die. We could do that, couldn't we? So we could say iter dot we want to do like all except the last one. Can you do that? I mean, we'd have to like, oh, we can reverse it and then skip one. Right, that'll be okay, because it doesn't matter what order we do it in, right? Skip 1. So now I think, oh, then why are there no tests? There should be a test for this, checking that if you hit the very last section of your body, it doesn't count as hitting it, because we're about to move forward and step that bit of your body out of your way. The other thing, of course, is if the apple is there, maybe we don't want it. So I can see we could quite easily add, if the apple's here, then it doesn't count. Let's have a little comment here. Hitting side, hitting body. All right, now let's make it move a little bit faster because it's getting a bit dull. So make our frames per second faster and run it. There you go. All right, so we can eat an apple, we get longer, we can hit this side and die. We can hit our own body and die. Now, there's a few things we should do here. First of all, we need to look dead in some way, don't we? So, should we make it just render the front of the snake a different color? So, if not snake.alive, then let's set our color to, I don't know, a darker green maybe. And fill the rectangle for the, let's make that not private, because it's relevant to people outside. And then we'll do let p equals snake.body.front, I guess. And it's never going to be empty, so we can just unwrap it. Maybe we should provide a function called front, which guarantees that there's always something. Alright, so now when we die, with any luck, we'll draw the front of the snake in a darker colour. There you go. So at least something happened, so you know you're dead. And the thing is that you can, what I just did then is I pressed down and the snake reversed direction and died. And that's bad. Like having implemented a lot of snake games, I can tell you the right thing to do when someone presses down when you're facing up is ignore what they pressed. So when they call set dir, we don't want to set it to the opposite of what it is now. But also I'm gonna store up dirs that they pressed, so it seems pointless to do this and then immediately change it again. So let's store up the keys that they pressed. So we're gonna have like let's have queued dirs, which is just going to be a vec of dir, which will start off empty. Now, should we put that next to dir? We should probably put that next to dir, shouldn't we? So actually, when you press set, when you run set dir, what it actually does is adds a queued dir to this and doesn't change the direction. I guess we should say if there's not too many already. Well, I guess, do you want to, should we just purge some if, hang on, we need a vec deck again, don't we? We need a vec deck because we want to push, yeah, we need a vec deck because we want to push them on the front of queued dirs, and then pop them off the back because it's a queue. So make an empty set of queued dirs. That should be new. Make an empty set of queued dirs, and then push one on the front. Should be push front now. And then, while there are too many, Wonder how many is too many. I think we shouldn't have more than 4. We'll just pop some off the back. And then every time we come in here, yeah, that's fine. Self dot dir. Well, it's if there is something on the front of this queue, pop it off. So pop the oldest direction that's been put into the queue off. No, this should be. Oh, this is not how you write Rust. So if some new dir equals the result of popping the thing off the back. So if there's one in there, set the direction to it. Right, so we've got this queue, and then we pick off the oldest one, and that's our new direction. Right, what happens when we run? Now we should be able to queue up a load of directions. Like so. It's kind of working. Not very reliably. Oh, it is when I type them right. So I guess we need a little bit of nuance to this. If you press right 17 times, we don't want to queue 17 rights. We only need 1 right queued. Okay, so let's do that. We haven't stopped ourselves reversing direction yet either. All right. So what was wrong there was it was queuing up tons and tons of just me pressing right, and that's no use. So when setdir gets called, we're only going to push one onto it if it's the one that's at the front of the queue is not already that. So if we've already queued it, we don't need it. So it's either if it's empty or it's a different direction, then we do it. So the only time we give up is if there's something there and it's the same. So if the direction, if there is a queued direction and the direction is, no, it doesn't like it. It doesn't like, well, it doesn't like comparing dirs, so we can do that. Oh, we need to do reference. But let chains are only allowed in Rust 2024. And for some reason, as we saw, our Rust edition was 2018. But let's make it 2024. No one else is using this code yet. So we can just say if this direction is already queued. Don't do it again. Do it again. Fine. All right, we changed Rust edition just like that. So yeah, that's what that was this thing of how an if let is combined with something that belongs in an if. This thing here, they had to do some changes to the way it works internally for some really weird edge cases. To make this chaining work. So they put it in the new edition, the 2024 edition. So we can happily use it. So now when I just press a random load of keys, it's kind of going diagonally. It looks like it's working to me. Yeah, it's working. All right, okay, good. So now we need to say, also don't queue if the opposite of a direction that's in the queue. So it was previously it was if there's something queued and it equals the direction we're already going. I guess we want to say or it equals our actual direction. Oh no, it was only if no. Oh, there must be a better way. There must be a better way. Okay, let's think about this. Let's use a match to help our brains think. So we're going to match on self.queueDoers.front. Two possible things. Either there's something in there, which we'll call D, or there's nothing in there. If there's nothing in there, the thing that we care about is... oh no, it shouldn't even be front. It should be back, because it's back that's going to get... Yeah, okay, that was why it wasn't quite working the way I thought it was working. So it should be back. So it's basically the next direction. No, that's wrong. It should be front. It's the next, it's the thing that's already queued. We're going to push something in front of it. There's no point having two that are the same next to each other in that list. So the kind of most recent direction is going to be either the front, or it's going to be, if there is nothing queued, then it's going to be self.direction. Is the copy? It's not, but it should be. Let's make it copy, like so. All right, so now we've got our most recent direction, which is either the front of the queue or our actual direction. And now if... hang on. And yeah, so that will always be something. That will always be... That can never be empty. So if direction is the same as the most recent direction, then quit. So that's that. But now we also want to quit if it's the opposite of that direction. So I guess we'll check this works first. Nothing's happening. Okay, that's because my cursor wasn't ending. Alright, so now it seems to me like it's queuing up things. Queuing up inputs a bit better. Looks good. The key thing is you need to be able to flip back and forth like this. So it needs to remember the next two keystrokes, so that you can do that kind of piling behavior. Alright, so that works, Okay, so still a bit slow, isn't it? Let's make it faster. What could possibly go wrong? Alright, so we want to also say, don't queue it if it's the opposite of, because you never want to go the opposite direction to the way that you've just pressed. So we need to make ourselves an opposite method, but we can do that. Oops. So we're going to make ourselves a function which is like this. If you're facing left, the opposite is right, and so on. And down is opposite of up, right? So now I've got an opposite function. We can say is already queued. This direction or its opposite is already queued. Don't. Just ignore. Ignore is the right word. Right, let's try it. So when I refresh and I press down, nothing happens. And then if I press down, there it works. So then if I say up, right, left. So if I say right, left, it doesn't work. I think I can't really confirm for myself that the queuing part of this is working, but it seems like it is. So okay. All right. And we can hit our own body. So that's still working. So we've got a game that you can play once that is pretty much a complete game. Is that fair? I guess there was a thing about being able to pass through your own body. Let's implement that for fun. So I think it's pretty straightforward. Again, tests are really needed here to make us feel confident. But yeah, when we're checking for a collision, we can check if you crashed into part of your body, that would be death, except if P is the self.apple. Now, just trust me, this means you can run into your body except when the apple is there. When the apple's on your body, then you can pass straight through it. So let's check you can hit your body. Yeah, okay. And then we're going to need to turn the speed up more if we're going to play a bit of this game to get to the point where the apple goes on your body. You can still hit the side. All good. So what we need is, we need a thing where when you press space, the game restarts. And we need to make it faster. I think those are going to be the two things we need. So how are we going to do that? So pressing space, we're going to have to come out to this on key down. Now, what's the key code for space? We better log the key code, I guess. So we're going to format a string with the key code in it, like this. Which will require us to bring in the console module. Key code shouldn't return an array, so what's it saying? What's wrong here? Oh, that should be log1. Yeah. The log takes in an array. That was what was confusing me. Okay. So let's run the game and press space a bit. And it should log out 32. I should have known that 32 was space, shouldn't I? Should probably go at the beginning. So we can get rid of all this. So when we hit space, we want like to call a function called reset or something that restarts the game, which is going to be, I mean, maybe it should just not call a reset, but just say self.snake equals snake : new, right? I mean, that seems okay. If there's any high score or anything in there, we'll lose it. So this snake thing is going to have to expand a bit if we do that. But we're not doing high scores today. I've decided. Okay, we don't need the console anymore. All right, so we should be able to... Oh, I need to be able to press keys. Actually, I really want to hit enter to reset. Let's do that. So what's the key code for enter? No, I need my console back. Like so. Refresh, press enter. 13. Fine. So 13 or 32 should do it if it lets us do that. Otherwise, do nothing. Get rid of console again. Happy with that? Run it. Let's not have a micro break. Alright, so when you die, you can hit enter to restart. You can die by hitting your body. Okay, so now let's have a play, see how well we can do in the game. And if we can, let's try and pass through our own body because there's an apple there. Because we haven't written any tests, so we have no idea whether our code works. What do we think of the speed of this? This is probably approximately the optimal speed for me getting a high score in this game. Oh, we've got to do some doubling back to... Oh, I died. Okay, we can do this. Just need the apple to appear on our body. And then, I don't know if you want to watch me try and get a high score in Snake. That was nearly on our body, wasn't it? The longer your snake gets, obviously, the higher the probability of hitting your body with an apple. We've come close a few times. There's one. Did it. Look, we went through our body. Okay, so, all right, so that really is it. I think we've implemented a decent snake game. I don't know how long I'll last playing this. I might have to fast forward it if it's too boring. Or I could play really recklessly and then you wouldn't have to wait long. There you go. All right, I died. Okay, so that was our game. Hopefully that was enjoyable. We basically made this snake struct with like the position of the snake, the directions that you pressed so recently, length of the snake so that it can grow, position of the apple, random number generator, whether or not the snake's alive. We just initialized it. We took some input and used that to set up our direction. And then every time step, check whether we're alive, pull the direction off the queue of directions, moved our front position based on our direction, used that moved front before it actually moves to check whether we died, check whether we ate an apple, move the snake, and then get rid of the tail. And then we had a couple of functions for what to do when you eat an apple, what to do to check whether you hit anything, creating a new snake at the beginning, making a random point, and then we had the rendering code. That's, I guess, the main other point is the rendering code. So we get hold of a canvas context, get hold of the width and the height of the canvas, we fill it in black, draw an outline around the edge, draw the snake body, draw the snake's dead head, and draw the apple. And that really is it. That is our snake game. Now, it's quite ugly because the pixels are massive. So the first thing I would do would be to multiply the resolution by 10 or 8 or something and have like a 1 pixel border so you can kind of see grid lines in between. Because that's the way I like my snake to look. And obviously I would need a high score table. Now, if you want to extend this, I will push this to my usual snake repository. What have I changed that I needed to undo there? Yeah, okay, we don't want that. I will push this to, it's on GitLab/Andy Balaam/snake, which all of my snake games are in there. And so this snake game will also be in there. I'll push it to there. So if you want to extend it, what I would do next is make a high score table. And in order to do that, I would not store that in Snake because you could see that we're like, completely replacing Snake, when you start a new game, because everything in here only lasts for one game. I guess maybe the random number generator shouldn't. That should probably, yeah, maybe you should pull that out as well. But anyway, the game thing currently holds on to a snake. And what it probably wants to hold on to is like a game state or something, which spans multiple games. And inside that game state, there would be a snake, and there'd also be a high score and maybe a random number generator, something like that. So if you fancy extending it, to make it like a better snake game with a high score table or just a single high score or whatever it is, that would be totally cool. I hope you enjoyed. I hope this was a short video. It wasn't, was it? I hope it was slightly shorter anyway. I hope you enjoyed. See you next time.